Moving on to today's model, here you can see an overall elevation in perspective of the bridge. This bridge is using a balanced cantilever construction method. As you can see it on the second drawing, the main span is 130 meters long and the ones on the side are 85 meters. Also, the pier is 40 meters high. So as you can see it on the drawing, the diaphragm just above the piers is the largest section, as this is attracting the most moment, and the segments that are constructed next to it are each representing one construction stage, and as you can see we have 12 of these, all of which are 4.75 meters long. Finally, as soon as the tapering has been done, the key segment will be put in order to connect the fully supported zone with the tapered part. In the left corner, you can see the diaphragm section. This is 24 meters wide and 6.5 meters deep. Also towards the center, we have the shallower section, which is 2.7 meters deep. We have a variety of tendons. So for the diaphragm, we have tendons which are jacked at only one end, and as the construction progresses, the tendons within the other sections are tensioned or jacked at both ends. The same applies for the bottom part, only in this case the tendons are jacked only into one direction, represented by the arrows. So let me move to the software itself. This is the MIDAS civil interface. At the top we have the ribbon menu, which is the latest technology of GUI. We have a variety of tabs, all of which are positioned in a logical order to help you in your everyday project. As you can see over here, the geometry can be defined, as well as the properties, the boundaries for this, the loadings can be applied, different types of analyses can be carried out, then the results can be extracted. Design can be carried out for PreStress Concrete and for steel reinforced concrete, and for composite design. And finally, we can generate the report. So let me move on to the Structures tab, which is the main focus of today's webinar. Here you can see that we have a variety of wizards for segmental bridges, suspension and cable stayed bridges, as well as for transverse and grillage models, and for more conventional bridges such as reinforced concrete slab and reinforced concrete frame and box covered bridges. So before I start with the balanced cantilever bridge wizard, I'm going to define the material and the section properties. So for that, just go to Properties, Material Properties, and here, instead of defining them from scratch, I'm just going to bring them in from a previous project. So just import and select the model. This is very useful, especially if you have defined your materials and sections in a different project. You can use this over and over again, so you can save a considerable amount of time. So just by pressing OK, you can see that both the materials and the sections have been defined in the dialog box, as well as these have appeared in the workstream. Now these are blue, that means that they are not being used yet. So also you can right click on these, go into Properties and check the standard which has been used for the concrete, as well as the strength of the concrete and the material properties over here. Okay, so by closing that down, we can check similarly for the sections, right click and Properties, and here you can see the parameters for the diaphragm, as well as the drawing for this. Okay, so let me move on to the wizard itself. So that's in Structures, Balanced Cantilever Bridge Wizard. In this dialog box, you can see that we have different types of bridges. We're going to use a type 2 today. all we're going to do is define the model information, sections, and tendons. However, to save up some time, I have already predefined these, so I'm just going to open up the wizard. So this is another advantage of MIDAS Civil Wizard, that you can generate the wizard and you can save this, and you can use it at a later point. So as you can see now, the numbers have been changed. Let me go through these. So here is the material definition for the girder and the pier. The section is defined for the piers. The number of piers can be defined. Also the dimensions of the pier table, key segments, piers, and for the fully supported parts. Okay. Also, because the software is going to generate us the construction stages, we need to define how long each stage is going to take. So that's done over here in the stage duration window, and we can also define the member ages. So just click on member age, and here we can define this for key segment, pier table, and so on. These ages will be used within the construction stages, which the wizard is going to define for us automatically. And finally, the different zones can be defined. So as you can see over here for zone 1, which is the tapering zone, we have 12 segments, each of which is 4.75 meters long. Moving on to the sections, we're going to have two sections, one at the center, so that is the shallower section, and one at the pier table, which is the diaphragm, and the software is going to generate the tapering from the diaphragm's size to the shallower. It also accounts for the form traveler load and the wet concrete loading, and as you can see, just by simply inputting the load and the eccentricity, these can be accounted for. And finally, for the tendons, here as you can see, the tendons are defined as per the drawings on the right hand side. We can see the sections that we are using, so the shallower and the deeper one. The number of tendons can be defined, how many tendons we want at the top, bottom, or the corner parts. Also, the offset for the tendon must be defined, and finally the anchorage for both the tapered and for the still parts can be defined. Finally, for the tendon properties, I'm going to define these now. So just click on the three dots, add, and I'm going to input the name, so tendon. These tendons can be external or internal. Select the material, and then specify the tendon area just by simply selecting the strand diameter and inputting the amount of strand. We can define the duct diameter. We can also account for the relaxation coefficient, so in this case let's use the European one, and also anchorage slip and the bonding type can be defined, such as bonded or unbonded. By pressing OK, you can see both in the dialog box and the worktree that this has been defined. And if I close this down, furthermore we can define the jacking stress, but for today's presentation I'll just stick to the default. By pressing OK, the software is going to the wizard is going to generate us the entire model, and on the left hand side you can see how the worktree has built up. So let's go through all the things that we have obtained. So as you can see over here, we have 83 nodes, 76 beam elements. Let me expand the properties. So no further material properties have been defined. However, the tapering has been done for us, so I can just double click on taper and activate this. And by rotating dynamically, you can see how your tapering looks, what your tapering looks like. Okay, and now I can activate the entire model. Moving on to the supports, we can right click on any of the supports and display, As you can see, these are all defined for us. Also note that we're using the hexagonal shape, which is representing the 6 degrees of freedom. We also have our elastic links defined for us, so right click display, and you can see these being displayed. Okay. So moving on to the loads, the software defines for us the self-weight as well as the form traveler load. So let's just display this, and in this case let's go through the construction stages. So one by one, you can just scroll through these and you can see how the bridge is advancing and how the form traveler is moving along this. Okay, and then finally the key segment is being placed there. The software also defines us the, let me undisplay this. Okay, let's save this as webinar. Yes. So the software also defines us the concrete loading, so we can display this as well, and this is defined for every single construction stage, and the pre-stress and other loadings as well. We can move on to the tendons. So let me display this, and for the tendons you can check each tendon one by one. You can also right click on this, go on to properties, and you can change the tendon properties for any of these. Okay, close that down. Let me show you the tendons first. So go on to tendon profile, and here you can see the tendons from the front view. So as you can see, we have the tendons at the top of the sections and as well as at the bottom of the sections. Also from the top view, you can see, if I zoom in, you can see where the anchorages are done at different points. Okay, so let me undisplay the tendons, and finally the last thing that the wizard generates for us is the construction stages. So we can check these as well by clicking on the construction stage icon and just simply double click on any other stage, and here you can see that the software defined for us the elements as well as the age of this. So these inputs are from the wizard, the boundaries, and the loadings. The software doesn't just activate any of the loadings, boundaries, or elements, but also deactivates these. So for example, in stage 2, as you can see, some of the loadings are being deactivated. Okay, so if I close this down, now that we have seen what the software, what the wizard generates us, we can move on to defining our own loadings. But first, let me define the material, the time-dependent materials. So from properties, we're going to define the creep and shrinkage. However, first let me change the units, so from kilonewtons and meters to millimeters and newtons. So we're going to do these in megapascals. Next, go on to creep and shrinkage, add, and just simply input the name as deck, define the code, and then just input the strength of the material as well as the notional size. By clicking on show results, the software is going to generate us the creep coefficient and the shrinkage strain graphs. You can close this down, and by pressing OK you can see that this has been defined for us. Similarly for compressive strengths, add, just input deck, again choose the code as Eurocode, and because this is the mean compressive strength, this will be 8 megapascals larger, and as you can see over here, software has generated us the graph. Okay, so now that we have defined these time-dependent materials, we actually need to connect them to our concrete. So in order to do this, we're going to material link and just simply select deck for both the creep and shrinkage and the compressive strength. Then choose the material and just have it as a selected material. We can add this as you can see, the connection has been made. If I close this down, you can see that the time-dependent materials turn from blue to black, which means that now they are being used and they are assigned to this particular material here. Okay, so moving on from the time-dependent materials, we're going to apply some loadings. So for that, first let me define the static load cases. So from load, static load cases, just specify temperature, and the type of this will be a temperature load. And by simply pressing add, you can see that this has been added to all the static load cases that the software has already generated for us. We can close this down. We can close this down as well. And now in order to apply the temperature loads, we can go on to temperature and pre-stress. But first, let me show you the kinds of the temperature loading that we're going to apply. So moving back to the presentation itself, I'm just going to move on. So for temperature loadings, we're going to apply a uniform temperature component and a nonlinear temperature difference component. As you can see it on the drawings as well, we're going to have A and D. Okay, so for the nonlinear temperature difference component, here you can see the drawing for it and the applied temperature loadings. So as per the drawing over here, we're going to apply DT1 as 13 degrees, decreasing to 3 degrees because our section is larger than 0.8 meters. And this will be from 0 to 0.15 meters, and then the temperature from 3 degrees is going to decrease to 0, which will be from 0.15 meters to 0.4 meters, and similarly from the bottom, we're going to have it from 0 to 0.15 meters, we're going to have a temperature decrease of 2.5 degrees to 0. So moving back to the software itself, we're going to apply these as element temperatures and beam section temperatures. So starting off with the element temperature, we have defined the load case for this as temperature, and we're going to have no load group name, as this is not going to be applied during the construction stages, but rather in the post-construction stage. So the temperature that we are applying onto this will be 15 degrees. Apply. Let me just select the element. So just from the front view, by selecting the tool, I'm just going to select the element and apply the loading onto these. Using the initial view, we can clear the screen so we won't have the loading. Let me just remove the nodes. Okay. Okay. Next, we're going to apply the beam section temperatures. So for this, the section type will be PSC, so PreStress Concrete. For the width, we're going to use the section width defined by the software. And as I specified previously, we're just going to input 0 and 115 50 millimeters, and the temperatures are going to decrease from 13 degrees to 3. And again, just select the elements onto which we're going to apply these loadings. This can be done by using the select previous option. So as you can see, the elements are selected, and now just simply press add. And in the same way, we're going to apply the other temperatures. So from 150 millimeters to 400, it's going to decrease from 3 to 0. Okay, and finally for the bottom part, it's going to start from 0 and up to 150 millimeters, and the temperature is decreasing from 2.5 Celsius to 0. And just press add. By pressing apply, you can see that all these temperature effects are being added onto our model. So I can close this down. Next, I will be moving on to the moving load. So just go to moving load, select the moving load code as Eurocode, and first I will be defining the lanes, then the vehicles, and then I'm going to connect them by using a load case. So just go to traffic line lanes and just specify the lane name as lane 1. In this case, let me change the units from millimeters to meters. It's easier to work with. And just going to specify the eccentricity. And this eccentricity will be taken from a reference line, which I'm going to define very shortly. So the first eccentricity for lane 1 will be 8.75 meters, and the lane width will be 3.5 meters wide. The lane we're going to specify by a number of elements. So for that, I'm just going to front view and just select the elements onto which the lane will be applied. As you can see it over here, these are selected, and from the elements window, I'm just going to copy these into the traffic line lane dialog box, and by pressing add, as you can see, the software has generated the lane onto these eccentricities, and by pressing apply, you can see that the first lane has been defined. Similarly, I'm going to do it for the other lanes as well, because it barely takes any time. So just change the eccentricities as we have lanes at different points, and just add these in with the new ones. Then press apply. Okay, so the same procedure will be done for the other ones. And as I got to the fourth lane, this is going to be placed onto the other side of the reference line, so this is going to be a minus eccentricity. Add this in, press apply, and as you can see, just in a matter of few clicks, we can define all of our lanes. Finally, the final lane, lane 6, and just simply apply this onto the elements and press OK. And now I can close this down. As you can see, just in a few minutes we have generated all of our 6 lanes from 1 to 6. Okay, so now that we have our lanes, we're going to define the vehicles. So for this, just go into vehicle, we can add standard ones or user defined. Today I'm going to add standard ones, and just simply press apply for LM1, and we're going to have an LM3 for SV100, and just press OK. As you can see, as simple as this, we have our 2 vehicles defined. So I can just close this down, and in the worktree you can see how these are being defined, and also that these are blue. Now, in order to connect the vehicles to the lanes, I'm going to specify the moving load case. So just create a load case, add, let's say, moving load case. The load model will be LM103 multi-straddling. All I need to do is specify the LM3 vehicle. I'm going to ignore the side factor and just simply select all the lanes and press OK. As you can see, this moving load case has been defined for us, and also the lanes are now connected to the vehicles. Now we have finished the moving load application. What we need to do is create one more construction stage so that we can account for the time-dependent material effects that we have defined previously. So for this, just simply go into load, construction stage, define construction stage, and add in a new one. So this will be a long-term one, and the duration of this will be 10,000 days. And in this case, because I just want to account for the creep and shrinkage, I'm not going to activate any elements, boundaries, or loads. Just press OK, and if you scroll down, you can see at the bottom that we have our long-term construction stage. Okay, now I can close this down, and our model is finished. So in order to save time, I'm just going to open the analyzed model. Okay, so over here you can see the analyzed model. For this, the only difference that I have made is the reinforcement is added in. So we can just double click on this and we can check the reinforcement over here. And we can also display the reinforcement as shown on the screen. Okay, so let me close this down, and now let's have a look at the results. So from results, deformations, displacement contour. One of the great advantages of MIDAS Civil is that we can check for the results in every single construction stage. So in this example, let's look at stage 1, the deformed shape in the legend for real displacement, and just simply press apply. And here you can see the deformed shape with the deflections, and also if you want you can change this to millimeters, so it's more convenient to see the displacement in millimeters. And we can just scroll through the different construction stages so we see how the structure is going to deflect. Okay. Similarly, the results can be checked for the post-construction stage for different load combinations. We can check for moving load as well. Moving on to the force bending moment, so forces and diagrams. And here let's see due to temperature, and let's see the solid fill. So I'm going to change the units to kilonewton meters. It's more convenient for checking the moment. And as you can see over here, that's the bending moment diagram. And again, this can be checked in different construction stages. So let's move on to the stresses. So for beam stresses, again, these can be checked for each construction stage. Let's see in stage 1. And we can just go through the different construction stage, how the stresses develop. And finally, we can check this in the post-construction stage again, and for different load combinations, as you can see over here. Okay, so now what I'm going to do is check for the moving loads. So let me just go to initial view, and using the moving load tracer, we can, for any given point on our bridge, we can find the most severe placing of the live load, So the software is going to generate the most critical live load pattern for that particular point. So for example, in this case, element 32, we can apply this, and let me take off the values so it's clearer. Okay. As you can see, here are the live loads for that particular point. Also the influence lines, the tandem loads and the UDLs are displayed. Let me show the legend as well. So here you can see the maximum value for the major bending moment, and on the right hand side you can see the influence lines and also the unit and other information about the particular point. This can be turned into static load case, and the coexisting forces can be checked for this. Okay, so let's move on from this to Camber. So the software is going to automatically generate us the Camber Graph. So we can check this, and for example, for the summation, by pressing OK, you can see that this is the Camber Graph that we obtain. It should be noted that for each node along the bridge, there are two Camber results. One for when the element is being placed, and one for the next construction stage when the next section is being placed, so you can tell how much the previous one has deflected. Okay, so we can close this down, and similarly we can check for the Camber table by pressing OK. We can check. This is the Camber control. So as you can see over here, these are the Cambers that we need to provide. And for example, in the case of node 12, this the Camber is being provided in construction stage 7, and throughout the different stages you can check how the deflections will change up until the point when the entire bridge deck is in level. Okay, so I can close this down. Moving on to the tendon stress losses, we can check these in the results tables. So tendon stress loss, and as you can see over here, the stress losses are broken down into different components such as creep and shrinkage, relaxation loss, and so on. We can also change the units, so we can see these in megapascals. Okay. And also this can be checked for different construction stages for different tendons. Furthermore, by right-clicking on the screen, we can check the tendon time dependent loss graph, and again this can be checked for each construction stage. Okay, let me close this down. Also, it should be noted that all of our tables are fully Excel compatible, so this can be exported into Excel and you can work with it over there. So, moving on from the stresses, we can carry out the PreStress Concrete design. So by defining the code to which we're doing this, we can define the parameters. Again, the design code, the national annex. We can define different strut angles, as well as we can specify our output parameters, such as for ULS and for SLS. And the design data can be specified as well. So for example, for the design material, here you can see that this has, I have already defined this, the code for the concrete and the grade of this, and also the compressive strength. Furthermore, the rebar data has been specified for the code and the grade of this. For the output positions, we have the design position and the output position. So for design, this is a very useful feature, especially when you're working with a larger bridge and you don't want to carry out the design for every single element in it. So what you can do is just select certain elements and carry out the design for these. So just by pressing apply, the design will be carried out for these elements. Furthermore, well, actually in my case I have carried out the design for the entire deck, as there are not too many elements. However, for the output position, I have only specified one. So the output position works the same way. We specify a section, and the software is going to generate for this an Excel report. And let me show you the Excel report. So this is the Excel report. This has been carried out for element number 51. The design conditions are shown, and all of this are in accordance with the Eurocode. So this is shown to you including the clause, so you can go back and check if you want. Also the moment resistance calculations and all the other checks are specified, and if these pass you have OK. If these fail, you just have NG, so you know where to go back and which parameters to change. So moving back to the software itself, here we have the bridge. So for the serviceability load combinations, we first need to specify the load combinations. So just go to results and load combinations, and within the concrete design, I have already predefined these. This can be done either manually or automatically. So, for example, with auto generation, just by simply selecting the code and here specifying the load factors, the leading variables, and traffic loads, you can generate all your load combinations. And as you can see over here, we have 3 for strength, so ultimate limit states, and 10 for serviceability or ULS. As soon as we have these load combinations, these can be put into the serviceability load combination type. So here, all we need to specify is whether these are quasi-permanent, frequent, or characteristic ones. Okay, so at this point we can perform the design, which you can see that I have already done. And from the result tables, you can check for all the ULS and SLS results. However, instead of showing you further tables, I'll just show you the PreStress Concrete result diagram. So for this, we can check for the force. Let's see, with the solid fill. From the front view, let me zoom in a bit, you can see how the barred part is very close to the solid fill. The barred part represents the resistance of the sections, and the solid fill represents the applied force onto these. Similarly, this can be checked for stress. So for example, for point number 3 and for compression, and press apply, you can see this is the distribution. The bar part again is the allowable stress, and the solid fill is the actual applied stress onto these elements. Okay, as we have finished with the design, what we can do is the report. So for this, let me just go back to results and let's see, displacement contour, apply. So for example, if you would like to input this picture into your report, you can just right click and click on dynamic report image and press OK. As soon as you do that, the software is going to save this and you're going to have it in the report tab. Let's check this for some tables. So the beam forces due to temperature, and just let's say for element number 3 and 4. Okay, so this can be again taken into the dynamic report table. Okay, and now as you can see, this has occurred in the table, in the tab. And when we want to generate the report, we just go into Tools, Dynamic Report Generator, and just let's create a new one. So here into this Word document, you can input any of these saved images or tables. So let's just start with the deformed contours. As you can see over here, the software automatically puts this in. Let's put in the tables as well. Here are the tables, and then we can input some section summaries as well. Okay, well, everything is in Newton millimeters. Let me change that into meters and kilonewtons. It's more convenient. Now that the units are changed, we can just simply go on to Dynamic Report Auto Regeneration. And for this, we can just simply select images, tables, everything that we want to update, and just click on Regenerate. And at this point, the software is going to automatically regenerate all the numbers for us. So as you can see it over here, it has been changed to meters. This is very useful if you're going to a meeting, for example, and then your model is being changed. You can just simply change the model, carry out the analysis, design, and then you can just simply auto-regenerate the report, and this will be all done for you automatically. Okay, so this is the end of my presentation. Thank you for your attention.